Let's look at the government budget constraint. So we've got this two-period model. That means we're going to have a budget constraint for the government now, and we're going to have a government budget constraint in the future. We assume that the economy begins life with some initial levels of debt and money. So then the budget constraint that the government faces today is equation 2. B negative 1 over P is the real value of the debt that gets inherited from the beginning of time. T minus G is the primary surplus. And this is seigniorage. So that's revenue from creating money. And what this says is that if you're running a surplus in the current period, or you are generating seigniorage revenue in the current period, then those things can be used to help to finance this debt that the government has inherited. But anything above and beyond that, anything that can't be financed, has to be financed by issuing more bonds. So they're selling more. B is the bonds that they sell in that initial period. Then going into the future period, well, the economy is going to end after that period. So there's no way the government can sell any bonds. So because everyone knows that the government won't pay them off. So that means BF has to be equal to 0. Again, what we have here is the surplus in the future and the seigniorage in the future. And I've written this in a kind of funny way because what's really going on here is, remember, the government's selling bonds that pay interest R. So 1 plus R is the principal plus the interest that the government pays times B, the amount of debt. And that actually gets divided by the price level in the future, because this stuff is all in units of goods in the future. And what I've done here is I've just multiplied by P over P for two reasons. One is you see the B over P that comes from this, what's left over basically that has to be financed in the first period. You can see it shows up in the second period. This actually is what links policy today to policy in the future, is the debt that the government carries over. And the second thing is, what is this whole term? Well, this whole term is 1 plus R divided by PF over P. You can see how you do that. Well, what is that? That's just 1 plus R divided by the inflation rate. So this whole term is going to end up using the Fisher equation to be 1 plus little r. And lo and behold, it's written down here, so we know it must be true. Okay, now let's rewrite equation 3 in terms of B over P. And you can see it's pretty simple algebra. We've imposed the Fisher equation. We just divide through by 1 plus r. And what we get is that the goods value, B over P is the goods value now of government debt. And what this says is that the goods value now of government debt equals the discounted present value of surpluses plus seigniorage. Why is this discounted? Well, because TF minus GF and then this MF blah blah blah, this seigniorage term, these are all in units of goods in the future. So we need to convert them into units of goods today. Now let's just define something so that we don't have to carry as much notation around. Make this curly S equal to the primary surplus plus seigniorage. So this is all the stuff that can be used to finance debt. And we'll have that in the current period, that's this term here, and we'll have it in the future period, that's this term here. So we'll also have an SF, which is just TF, GF, seigniorage F. All right. Now, we can combine, we can then rewrite equation 4 as B over P is just equal to SF over 1 plus R. So that's the present value of this sort of grand surplus object. And then the budget constraint today can just be rewritten in terms of this curly S, as this looks a lot like just the change in bonds equals negative surpluses, which kind of makes sense, right? If you're running big surpluses, then you're actually going to be reducing the amount of debt that you have. Or we can combine equation 5 and 6 because they both involve B over P. And now what do we get? Well, on the left-hand side, we get the goods value now of initial debt. And that's equal to whatever the grand surplus is today plus the present value of the grand surplus in the future. So equations 5 and 7 we're going to be using quite a bit. They are both equilibrium conditions. So how do we understand what this is? Well, equation 5 says that the real value of debt has to equal the present value of surpluses plus seigniorage. So what is the usual thought experiment? So here you want to be thinking Ricardian experiment. The usual thought experiment is, let's cut taxes today, finance them with more bonds today, and then raise taxes in the future to pay off all those bonds. That's the standard Ricardian experiment. Now, in this experiment, these bonds are supported by future taxes. And all of this works fine so long as monetary policy is determining the price level. Because you notice when I went through this little thought experiment here, I didn't say anything about the price level. So implicitly, what I was assuming was that somehow P gets determined by monetary policy, and when we do this fiscal experiment, we don't have to think about it.